All right. Here's our problem. Determine whether the following matrices are singular or non-singular. So what does this mean? I don't know if this definition is just for the textbook that I'm using, but applied linear algebra. But essentially what they mean by non-singular is that Gaussian elimination actually works. Okay. If Gaussian elimination works, then the matrix is non-singular. I think it's kind of confusing to call it that, but that's what they did. So let's just do some Gaussian elimination. We love it. All right, Gaussian elimination. The process is first get this one. Let me write it out so you can see. 4, 5, 6, 7, 8, 9. Essentially, we want to get this one first, then this one, then this one. Okay, we want to start under the first pivot and keep going under the second pivot and so on. So, how can we get rid of the second row? Well, since the first row we luckily have a 1 here, we just have to do, this is R1, this is R2, this is R3, that is not looking at 2, R2, this is not looking at 3, R3. What we're going to do is take negative 4 row 1 plus row 2. All right, let's do that. First two rows are staying the same. The second row is changing. So negative 4 times 1 is negative 4 plus 4 is 0, which is what we wanted. Then we have negative 4 times 2 is negative 8. Negative 8 plus 5 is negative 3. Negative 4 times 3 is negative 12. Plus 6 is negative 6. Okay? We got rid of that one. Now we just need to focus on the 7. How do we get rid of the 7? Well, same thing. Negative 7, R1 plus R3. Let's do that. All right. Rows that are staying the same are the first two. The third one's changing. So 7 times R1, 0 plus R3. Well, 7 times R1, negative 7 plus 7 is 0. Negative 7 times 2 is negative 14. Negative 14 plus 8 is 6. Yep, negative 6. So negative 7 times 3, negative 21. Negative 21 plus 9 is going to give us 12. Negative 12. All right. Next, we need to get rid of the negative 6. So 2 times what? We'll get rid of negative 6. Well, 2 times 3. So we're going to do we actually need to do the second row. Okay, so we're going to do, because we have a 1 right there, it's going to mess things up down here. So negative 3 times what? We'll get rid of negative 6 equals positive 6. Negative 3 times negative 2. So negative 2 row 2 plus row 3. All right, I almost made a mistake there. My whole life is a mistake. Okay. So these rows aren't going to change. I hate this 6. Let's get rid of that. So negative 2 times 0 plus 0 is 0. Negative 2 times negative 3 is 6 plus 6 is 0. 0 there, 0 there. Negative 2 times negative 6 is positive 12. Oh no. Plus negative 12 here is going to give us a 0. Okay. So did Gaussian elimination work? No, it didn't. We got a free variable on the bottom. Gaussian elimination did not work. We cannot solve. So therefore, we know that this is singular. Now let's check the solutions to make sure I'm right. Two dot 4.1 E is the one we wanted. Answer is singular, so we are correct. All right, let me know if you have a better way of doing it or if you have any questions.